Alright, first things first, we're going to start off with my ball. You know what? Actually, no. We are going to go to controller. We'll start with the controller, and then we will switch over to the actual turret itself. Alright, so what we have, we are writing in PRC. I am writing in PRC. We're going to start by including our standard IO. We have standard lib. This is for uints, and that's pretty much what I use it for. And then I've got my poly tools here, which is just a header that I've created with a bunch of other kind of conjoined headers, stuff like that. Just kind of keep everything in one place and make it a lot easier to actually access. It's made using all sorts of my different programs, making them much easier. So we are back on ball turret controller. Now, let me actually show you. This is what we're actually talking about. My ball turret or my controller, my RC controller. Yeah, RC controller. It's got an NRF24L01. That is my radio module. I've got a 1602A LCD. I had wanted it to be the 2004A, the 4x20 4-line one, but I messed up the PCB itself. I don't have any caps that fit both of them, and this cap here really is just a test. It doesn't fit exactly. It's kind of off on some of them. I have two buttons here, and up here this is supposed to be for the power button, but again, test fit. This little one here, there's 4 LEDs in there. All that does is show up when this is actually displaying something to screen, and that means for me, so I know that the NRF is actually transmitting, which we will see in the code at some point here. Now, this thing's pretty fun because it can work for both my ball turret program and my RC car. And I think either tonight or tomorrow I'm going to start adding code where I can actually set the channel, where I can set the baud rate. I think those are really the only two things. And I guess the data speed that I actually want to use, so that I can just use one controller, and I can, when I turn it on, I can switch between either my ball turret, my RC car, or any other device that I make that uses the NRF24. And that way it'll be easy to switch between them. I don't have a way to save stuff or configurations yet. I suppose I could just choose which configuration I want, and then kind of save those presets. But I think it'd be cool to be able to actually choose the channel in case one channel doesn't want to work, and then I can alter it. But I'm going to put that down, and we'll go back to the code for now. So what we have up here, I've got a couple macros. Just the first one is just to tell me if something's between two values. I don't know if it's the easiest way. I don't know if it's the best way. It's the way I use it. It's worked for me. I'm not a college software developer. I wouldn't call myself a developer anyways. However, so that means that I don't know if it's time compliant, I guess. I don't know how fast or slow a lot of this stuff is. There's a lot of stuff that I don't know. I'm just trying to give you how I know it and how I use stuff. So second up, we have our turret button 1. These I have shorted essentially because I have multi-level structs that have both buttons for the GPIO selection as well as the actual bool values, the volatile bool values. And then this way I can just pull them out without having to type out the struct the entire time. The same with fire, angle, and turret turn. You can see here that that's pretty long. It's turret load, and then I have ready load, And then I've also got a buffer load. Don't really need these, but I wanted to try to make something more generic in case I did. At the moment though, I'm just using ready load for both controller and receiver. It just makes it easier at the moment. And then, so it's ready load, and then I've got load vert data, which is vertical. It's also got horizontal, it's got raw, and then I've got vert loader, vert lower, because it's a struct there. It's upper and lower. I'm sending two 8 bits to that I will conjoin into a 16-bit. And then next up I have our laser patterns, which are for, you know, I can just show you this part. This here is the bottom half of the turret, the second try. These servos weren't enough to turn it, but essentially a 5mm red laser diode goes in each of these on the inside, and then it's controlled via a 74HC595E shift register, and it's just I disregarded the 2 upper bits. Depending on how you set it out, I guess everything goes towards H. Anyway, so I disregard A and B, and then I use the lower 6 to control these, and as these are the choices. So this is during the actual, this is for the controller, which we'll go back to here for that. For that, I push the bottom button. That will stop this. It will bring me to what I call my firing selection, and then I can add or subtract which pattern I want. I've only got 3 at the moment because it's only 3 per side. So I mean, I can do either 1 firing like this, 1 2 3 1 2 3, or I can do 1 2 2 3 3 1, back and forth all the way around, or I can just do what I call destruction beam, which is all 3 and it just boom 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 pulses. So at the moment it's just the 3 of them. And then I've got a couple random variables. My code's a mess at the moment. It's not really set up perfectly yet. I wanted to make sure, I like to make sure everything works first, and then I can actually kind of clean it up and flesh it out. But when it works, it'll get all cleaned up. And that way I can actually, I don't want to say push to production because I'm not pushing anything to production. I can just share with anybody who wants to know and see if they could use it for a Pi Pico as well. That's the microcontroller I'm using. There might be, I would like to set this up eventually, a long time from now, because I don't have that skill to set it up for different microcontrollers. Anyway, so I've got my volatile menu, menu selected, menu selection, and previous menu. We'll get to those once we get down. Below that, I have a struct called typedef struct register LCD that I called 1602 pins. That's so that I know what my struct is used for. I have another struct in a different header that is just register pins, but this one is for my LCD specifically. That's why I'm using it. But I'm also using that same struct in my receiver for just for the lasers. So I'm doing that there. Let's see if I can find a shift register. It's 4 pins that you need for the register, but I don't actually need the register for the 1602 because it's still using 6 wires, which I was hoping not to do, but I frustrated myself trying to set it up without that, because I could just use the shift register itself, 4 wires, I think I could, and then pop out the 6 needed wires, which would be my data for the display, and then my RS, which is your chip select, which if you're writing data or if you're writing a character, and then your E, your enable. I had an issue with that, let's just say that. I tested trying to do that many times. And then below that, we've got calc servo output angle. This is just a quicker way to set a output angle, essentially predetermined value, but it's taking in an analog input, which is one of my analog sticks, and I have it mapped between 0 and 255. So the input is between 0 and 4096 because it's the PyPico has, if I'm not mistaken, a 12-bit ADC. Take that value of 4096 and I'm mapping that to a 255 value or a 8-bit. And that way it's just a little bit simpler for me to actually go through the code because variables and values to go through. And then so this is a uint16 return value, and that just means that I am taking my turret tilt angle, which is a const, and then if I go to that, that's just right here, that's I have a servo motor header, and that's just my turret tilt angle. It's got different values, as you can see here, minimum turret value, center position, max turret position. You will see possibly in my turret ball that the 2343 is not my center position, and that is because the way I have it angled inside of the ball, it's actually kind of at an angle already. So horizontal or vertical is not center. Center is actually closer to like 1300 or something like that. So back to our controller. After we have found if the value is mapped between these inputs here, or these set values, we will set our output buffer and then return it. And then I have my calculate turn and that's a uint8 value. So we're just going to take in our analog input horizontal. Actually, the servo angle is the vertical. And then our turn value is just between three values because we're either going to turn left or we're going to turn right. And if we're not getting a value that's either one of those, hold it idle, keep it in the same position. All right, and next up we have I have a turret buffer. This is essentially just, this is one of the things that I'm sure is probably bottlenecking my program. It's not sending data as quick as I want. It might be, but I'm not probably using it correctly. And I could use help with that. But first thing I'm going to do is I have a splitter value, which I actually have essentially gotten rid of because I don't necessarily need it. I might still for some. But then I'm going to have my function, which is called ADC pin call, which I can get into. I'll go to it so you can see what it looks like. And oh, look at that right there is the map. So that's that's your mapping value. And here is what I wrote for that. It's a long map function. It's standard, I think, or very common for ADC mapping, probably other things. You have your X, which is your input value. You have your input minimum. You have your input maximum, your output minimum, and your output maximum. So say your input minimum could be negative values as well. And then you have your maximum, and then you have your out, which is what you want it mapped to. So say between 0 and 255, like I'm doing. Or you could also do between, say, you're trying to control a SG90, one of those little servo motors, one of these guys right here. The way I have my program set up with the code, its values are a minimum of, 400 and 2200. So you could essentially map it between those two values as well. All right, and then we'll go down a little bit just to show I think I've actually cleaned it up a little bit. So we're gonna, via the Pico code, we're going to select which ADC input we want. So I'm going to select 0 at first. That'll be my vertical. And then we are going to, I think this is actually a different, I have changed up the code. That's okay. It's essentially the same thing. We have our ADC select input. So we're going to read each input individually. I think I have it set so that if those inputs are initialized, then it will only read those, so that I'm not reading an unnecessary input like ADC2. So it can read those, and then it will map those values, and I should actually probably use DMA to go straight from the mapped to where I want to store it, or right to FIFO actually, which would be my RF. So I could just have that value mapped, have it buffered, and then transfer it directly. Maybe not DMA because it's SPI. From what I understand, that's a state program. So we go there. Now we'll go back. All right, I got my buffer. So from my buffer, which has ADC pin call, so it's going to read the horizontal and vertical. And what that's going to do is it's going to send my ready loads for vertical. It's going to set upper and lower. Upper is definitely going to be just 0 because it's not needed. I just wanted the upper and lower, both 8-bit to make the 16-bit, in case I do want to just send a 16-bit value, so pre-mapped value, and then I can send that to the actual turret or the RC car or whatever I'm using. So this way I can do either just 8 bits on either, or just the lower 8 bits, or I can have full 16-bit rejoined together after it's been sent. The same goes with the horizontal that I am actually using the calculate turn enable. So that is just going to calculate if it's turning left or right. And then we have our raw. That's one of the structs I mentioned. It is just going to be 0 on the top, and we're just going to do our input pattern, which is going to be, if we scroll back up here, it's going to be right here, menu selected, which you'll see what it means in a second, or a couple, yeah. And then, okay, so we've got that pattern, which is right here, input, or we got our UNIT pattern, and then we're going to end that with lower 2 bytes. Needles, I don't know, I can't remember at the moment. FF, so we'll have any value between 0 and 255, that, well, actually 1 and 255, not 0. 0 won't and then we also have this little fun guy right here, which made this program possible to fire with just my 2 buttons. We have my turret button too, which I've already said was a macro. And if that's true, so that's the status, that is the volatile bool, which is in an interrupt function. And what that's going to do is it will set that raw lower to, it'll OR it with 0x08. So that pattern is either going to be a 1, 2, or 3. And then what that means is that it'll set the 8, and then when it's transferred over to the actual ball turret, what it's going to do is it'll check for that each time it reads it, and if it determines that bit is there, that flag, it will pause it, pull it out of the while loop, and it'll fire those lasers. And then it just sets that to false. And then here we get to main. Main, here I have my menu false, my menu selected, and my menu selection starts at 1. Because if it starts at 0, I don't know what I did. We could look at the code together. That kind of broke. But we're going to do stdio in it all. That's just going to set it so that we can use print. And then I have RC controller program initialized, and I haven't changed it yet. Irrelevant. And then we're going to sleep for an arbitrary amount of time. This is how I debug. I set it for about 14 seconds total. That way I can actually go down here. I can do my devices. I can load in which Pico I'm using, because I have 2 that I'll connect. I have my controller and the ball turret. And then I'll open my terminal, and I can Pico com them. And then I can see print stuff, printing debugs. From after that, it's going to initialize my ADC. It's going to initialize the pins that I have set for that, which are going to be 26 and 27, ADC 0 and 1. And then I have my interrupt input initialization. That's got my buttons. So button 1, button 2. I don't, on this PCB, actually have either of the buttons on these set up. I could, that'd give me 2 more buttons, but that would also be another PCB redesign, and those prices are insane to buy new ones, so shipping is at least. And then next up we have our setup registers, and that's just going to set up my pins, which I just like to cut them into pieces so that I know what I'm initializing. That has my struct passed to it. And then we'll go, after we've set up register, we're going to sleep between each of these just because we don't have to. And then we're going to set up the LCD, which is going to send a couple different commands that are needed to actually initialize the LCD. For the 1602, it's actually different than the 2004A. So there's different commands that are needed to set. And then I like to write an intro screen, which is just saying Alphonse, or my name, and then it's version 1 currently on the controller. And then I'm going to clean that and clear that display. Next up we have our NRFT client, and that's my NRF. I'm not going to describe this because the NRF driver is not mine. It was created by AndyRids. I will link it with the video to his GitHub, but that's what I've been using. And then down here we start our while loop, and we're not gonna exit it, so we're gonna leave it at 1. We're not gonna have any return value for it. It's just gonna keep going and keep going. Next up, something that I learned during a different project from my brother-in-law, which was my beer rating system, was how to make a menu. And so I have well not menu, so that variable up here, menu, and then menu selected. So what's not menu is going to determine if that first button, actually this button, this is button 1, this is button 2, if button 1 isn't pressed, or I should say actually in here, if it's pressed, we're going to set that menu variable as true, and then we're going to, we don't need the sleep, that's just there for me to debug again. We're going to break out of this loop without testing anything else, and we are going to go down to this. This is going to be true. We are also going to reset the buttons in between these two, because after it breaks out of this while loop, it's going to still keep executing code, and it's going to reset the buttons, which really is just a function that says set it to 0 or false. It's nothing interesting there. It should be pretty easy to understand what's happening. And then inside of this well menu, like it says here, inside menu loop, we have our menu selection 1, and well, our menu is not selected, and that is going to be done through button 2. So what we're going to do is it will just keep going over and over through this switch statement here. To actually calculate that value, we have our stick menu here, which is just another mapped between. And if it's mapped between a certain value up, it will increase that value. If it goes down, it'll change it. And then it will display what pattern is actually going to be fired. So it's a written way of showing me what pattern I'm doing. I have single barrel, I've got dualies, and I've got destruction beam. Then once I select this, once I push this button, it will take that same value, that is our menu selection right here. So that's our menu selection. That will also be passed to our switch case, so it'll tell us what we're doing, but it's also just, it's a dual purpose. It's being used in 2 different ways. It's not only going to be used here in our switch case, because once this is pushed, it will test that menu selected, or the turret button, that'll make this while loop break, which will then set our menu here as false, which that's what we need to go back up here, and we'll break that. And then we actually want menu, wait. So we also want menu selected to be false, so that when we go back into this menu, it'll reset. I had trouble with that before. I had forgotten about doing that, and it wasn't going back into the loop. So I had to just set that false there. And then we're going to reset the button so that both are false. 1 and 2 are false again. And then we're going to go back up here to our menu. And here we have some testing that I did. It's more or less testing for normal NRF operations. And I have a bypass so that it sets up initial bypass. If it is initial bypass, it doesn't reconfigure anything. If it has no connections, which I have set up in this function here called NRF RC update, what that's just doing is that's taking my values. So let's go through it, I guess, a little bit. So while our NRF testing is not reset, well, that's not true. That is a bool. We are going to buffer our data, and then we're going to go to our RC update, and from there we have 3 times we are going to go through this. We have our packet transmit inside of this, which is going to send, which I suppose I actually need to go to, because all that's doing really is going through a switch with the load number. So if the load is 1, we will actually write or attempt to send data to pipeline 1. Now, like I said, I'm not going to describe all of this because it's not my code. I will do my best to. So we have our transfer destination, which is going to be our pipelines. And those are just register addresses that's currently set for 5 width. And then I have my address set so that it'll set the address that I want to write to. So it'll set the case that I want, and then it'll set the address. Because I could write data from 2 to address 1. So I could set my, I think, horizontal data on pipeline 1 or 0. And then this part is mine. I wanted to check to see how long this actually took to perform the transfer operation, and then I print off if it was successful. Well, actually that should be here. If success equals send packet. Again, send packet is part of the NRF driver, not my code. But we will finish and see if it see how long that took, and if it's successful, we are going to send this transmit NCS to 0. That just means no connections. NCS, no connections. And then we will print out a verification of what was actually sent. If not, we'll just say packet not sent. All right, that's the NRF packet transmit. I suppose I didn't finish all of that. Go back up. So we'll get rid of the switch case, and then, so if I don't have a valid number for what the success is yet, because it's an error. If there was, I don't know if it's an assertion error or what it is technically. It's an enum. So when I try to do a different value than something that's not what success is, tends to throw an error for my compiler. Either way, I will either set that no connect to 0, or I will increase it if there are no successes. So if none of those 3 are successful, it will increase that no connections by 1. And then here, down here in the NRF RC update, it's just sending that code via 1, 2, and 3. And then it's checking if the transmit is less than 59. It's just an arbitrary value I chose. I didn't want it to be too low. I don't want it to be too high, because I don't want it to just constantly not work. I didn't want it to be like 100, 200 or whatnot and just not send data. But I also didn't want it to just try resetting every 10 times, because sometimes it goes up to 8, sometimes it goes up to 9, maybe at 13, 18. 59 seems like a pretty good value. So if it is above that, it will set the NRF or reset NRF to true, and that will go back here. Well, that's not true. It won't. It'll just keep doing the same thing. It'll buffer. It'll send the data, and then it will write it to the screen. So what it's doing is it's taking that data that was read, and it's just going to say firing angle or turning left or right, and then yeah, I mean that's pretty much it actually for the controller. It's I think it's pretty simple. It needs to be worked in a little bit better because I think some of the values I could send faster. I mean, I don't know data structures, so I don't know how I could actually take this buffer or the ADC and actually turn that into the value that I want faster so that it can be sent faster. Although it still is some issue with the actual sending stuff at 1 megabyte. But I don't know. I think, yeah, that's pretty much the controller itself. So I guess we will see if that goes well, because then if it does, I could actually describe the circuitry in here for how I set it up, because I designed the controller itself first, the PCB, before working on the actual code. Well, this code. My RC car kind of worked on it in conjunction. I would write some code, see how I wanted that set up on the PCB, and then I would test it with just some good old-fashioned breakout boards. This one isn't the thing. This is just for something else. But that is essentially how I got that to do that. I mean, if you guys have any questions, please, or corrections, please let me know. I really could use the help. It's not fancy. I'm no computer scientist. I'm just a guy who self-taught himself some stuff. Stuff turned out to work, and he continued to do that. So I think for now, guys, that's all I have to say. Deuces.